Today we'll talk about the rational root theorem. Start with your original polynomial, get it set up for synthetic division, and test your first possible rational root, in this case a 1. Usual synthetic division rules apply. You multiply by the possible root and then add. And the last number you get is your remainder. In this case you get 2. We're looking for a 0, so that means 1 is not one of the roots of this polynomial. So test the next one, -1. Again, standard synthetic division. And this time you got a 0, which means -1 is a root of the polynomial. So you can rewrite the polynomial slightly factored using the result from the synthetic division to find the rest of the polynomial. The factor is x plus 1 when the root is -1. So we know -1 is a root, so we'll use the new lower degree equation in the synthetic division to test -1 again. You always want to keep testing something that you find to be a root to find out if it has multiplicity greater than 1. In this case, the result is not 0, so -1 is no longer a possible root. So now we're trying 2, and it works. So you can write it in more factored form, again using the result from the synthetic division to get your coefficients. And now you ended up with a quadratic. And quadratics you already know how to solve. You can factor, you can use the quadratic formula, whatever makes you happy. I chose to factor, so I end up with 2x minus 1 times x minus 2, which means the roots are 1/2 and 2. I can rewrite it in fully factored form. And then since there are two x minus 2 terms, I'm going to combine them for my final answer. X plus 1 times x minus 2 squared times 2x minus 1. And you now have a fully factored polynomial.